Okay guys, so looking at section 2.4, first of all, average rate of change. This is basically the same thing as slope. So this is just going to be your y2 minus y1 over x2 minus x1. In your homework, they're just going to ask you one question about average rate of change, so just be aware that it just means slope. Okay, next, talking about how we write quadratic equations. Okay, first of all, you could be given a point in the vertex. So that would mean that you would be given an xy and you would be given an hk. So if we're given an xy or an hk, actually we have to be given both of those, this is the form we're going to use to come up with the equation. We're going to be plugging in for y, we're going to plug in for h, and we're going to plug in for k, and we're going to plug in for x, and that's going to allow us to be able to solve for a. So if we're given a point and the vertex, that would be what we want to use. Now, remember another name for the vertex, it could also be called a max or min, right? And that would be the vertex. That's the same thing as giving you the vertex. So just be aware of that as well. So what if we have to come up with a quadratic equation and we're given a point and the x-intercept? Well, in that case, we could use our intercept form. So we would plug in for x and y, for this one too. So plug in x and y, and then also plug in for your p and q. And then you could solve for a. And then you would just rewrite the equation. So we've got this method, that one. Our third method is if we're given 3 points. Now, your book wanted you to have to write and solve a system of 3 equations and 3 variables. We did that on our last test. Do you guys remember doing that? And we don't want to have to do that again. You proved to me that you can do that. So we are going to use our graphing calculator anytime we're given 3 points. When we use our graphing calculator, we're going to get y equals ax squared plus bx plus c. The calculator is going to tell us the a, b, and c, and then we'll have the equation. Okay? So you can already see that these 2 types of problems could be on the non-calculator part. This kind of a problem would need to be on the calculator part, because I want you to use your graphing calculator. The fourth method is if we're given the focus. Axis of symmetry really wouldn't be a part of this. It's really if we're given the focus, the vertex, or the directrix. Any 2 of those. So if we're given the focus and the vertex and the directrix, the focus and the directrix, any 2 of those, we're going to want to use our y equals plus or minus 1 over 4p times x minus h quantity squared plus k. And we're going to use that. That's going to be if it opens up or down. So opens up or down, we're going to be using that. If it opens left or right, that's when we're going to have to use x equals plus or minus 1 over 4p times y squared. We're not going to shift the vertex on you on this type. Okay, let's do this example. Let's change this to a -8 though, and this is going to be an 8. Alright, so try this. Write the equation of a parabola with a focus of -8, 0 and a directrix of x equals 8. So we're going to look at which of the 4 methods we're going to want to use. We're going to look at what we're given. We're given a focus and a directrix. Focus and a directrix. So we want to use our method 4. So we got to decide, is this opening up or down, or is it opening left and right? What's the best way to figure that out? Kara, what would you do to figure that out, if it opens up or down, left or right? You don't know? Anybody know? What do you think? Yeah. I would do a little graph to look at that focus. So negative 8, 0 is there, and then x equals 8 is here, okay? So remember how the parabola cannot cross the directrix, right? So if the parabola can't cross the directrix, which way is it going to have to open, everybody? To the left, right. I should say correct instead of right. It's going to open to the left. So here's the way it's going to look then. It's going to go like this, go out this way. Okay, so Daniel, what does that mean then? Is it going to be x equals or y equals equation? X equals, so it's going to be x equals. And then we have to do, if it's opening to the left, it's going to have to be a negative 1 over 4p y squared. So the only thing left to figure out is what's that p-value. Gabby, do you know how to find the p-value? And why is it 8? Right? The reason that the p-value is 8 is because that's the distance from the focus to the vertex, or the vertex to the directrix. So the p-value is 8. So then our equation must be x equals negative 1, 4 times 8 is 32 y squared. And that would be our equation. Okay? Any questions on that? All right, let's go over to the next page, 42. Alright, so we're just going to do the first one, and we're going to do the last one. Let's look at what we're given. We are given the vertex here, and we're given a point x, y here. So you can either look at the other page that we just did, or you can look up here. So if we're given a vertex and a point, we're going to have to use this method, where we have y equals a times x minus h squared plus k. We should be able to substitute in for y. Y is 6. X is going to be 4. H is going to be 2. And k is negative 2. I'm just going to make that minus there. So we have to solve this. Be really careful that you do square this value. 4 minus 2 is 2. Square it is 4a, and then we had minus 2. So solving this, did you get the right answer? Check up here and see. Make sure that you don't have a equals 2. You have to be careful right here. This is a common mistake. We have 4a equals 2. Divide by 4 and you get 1/2 for a, not 2. All right. Let's go ahead and take a look at number 5. So on number 5, we actually have 3 points given to us. But these 2 points happen to be x-intercepts. See how that's an x-intercept and that's an x-intercept? Okay, so we might want to use our intercept form. So our intercept form states that we're going to do y equals a times x minus the first one, so which would be plus 4, and then x minus the second one, which is 6. See, this is our p, and this would be our q. So I also want to plug in for x and for y. So here's my x and y. That's P, that's Q, x and y. So y is 25, A we don't know, x is 1, x is still 1. So we're going to have 25 equals A, that's 5 times negative 5, so that's negative 25, and so A is going to be negative 1. And so now we can write our equation. Y equals negative x plus 4 times x minus 6. And that would be our equation. Questions there? Okay, so now go ahead and be trying number 8 on your own. I'm going to be doing it up here at the same time, so if you get stuck you can look to see if you can do it on your own. I'm going to know both of these are divisible by 9. Did you guys know this rule that if the digits add up to be 9, then it's obviously divisible by 9? So simplifying this, dividing this by 9, I can go down even further. Okay, so that simplifying was a little bit tricky there, but actually both of these ended up being divisible by 27. There are 4 27s and 108, so that's the reason it went down to that. Okay, questions? All right, let's go over to the next page. It says, in exercises 9 through 11, analyze the differences in the outputs to determine whether the data are linear, quadratic, or neither. If linear or quadratic, write an equation that fits the data. Here's the thing, guys. If our first differences are the same, the function is linear. If our second differences are the same, then the function's quadratic. So let me show you what we mean by that. So first we have to analyze the x's. We have to make sure that they go up by the same amount every time. Those are going up by 1. So now we're going to check this. This I'm going down by 8. Here we're going down by 40. Here we're going down by 72. Here I'm going down by 104. And here we're going down by 136. Those are what we call the first differences. So those first differences were all different. So therefore this function cannot be linear. These were my first differences. So now I go with my second differences. So to go from -8 to -40, that's down 32. This is down 32, that's down 32, and so is this down 32. So see how the second differences are all the same? So that means that this data is going to be quadratic. And it does say to write an equation that fits the data, but we're not going to go through that for this problem. We will here in just a minute. Okay, let's go on to number 10. We check the x's. They're all even, so that's fine. Check your first differences. That's going to be down 6, down 6, down 6. So what does that tell us then when it's like that? Logan, what do we know about the data then? It has to be what? Linear, because our first differences were the same. Okay, and then just real quickly checking this. This is up 10, this is up 30, this is up 90, this is up a lot, that's up even more. See, we don't have to do the whole thing, do we? This is up 20, this is up 60. So I already know that my first and my second differences are not going to be the same, so this is going to be neither. My point there is that you don't have to really check them all. As soon as you get something you see isn't going to work, you can stop. Okay, now let's go down to number 12. The table shows a university's budget in millions of dollars over a 10-year period, where x equals 0 represents the first year in the 10-year period. Use a graphing calculator to create a scatter plot. Okay, so get out your calculator, and we're going to put in this data. So to do that, remember that we're going to clear everything out, anything you have on your home screen, anything you have under y equals, get rid of it all. Go to your stat, and we're going to edit them. If you have something in there, just go ahead and clear it out. We always want to use L1 and L2, so I'm going to go ahead and type in my data. So just putting in the numbers under our stat, edit. We always want to make sure we have the same number in L1 as we do L2, so we're looking good there. Okay, and it already told us that this data, well, it asked us actually in the first part, use a graphing calculator to create a scatter plot. Now, we haven't done this yet, I don't believe, so go to your window first of all. We're going to set up our window. Our smallest x is 0, so I'm going to make this 0. Our largest x is 9, so 10's good for my x's. For my y's, my smallest y is 22. I might want to make this 20 just to be able to see everything. And my largest y appears to be 150, so I might want to make this 200. Now, if I hit graph right now, I'm not going to see anything. That's because my scatter plots aren't on. So go to y equals, and now go up to plot 1 and hit enter. That's going to turn on your stat plot. So now hit graph. See how now we can see the point? Okay? This is not going to be, it's definitely not going to be linear because we have this dip and then we go back up. Okay? It's not great at being quadratic because it does appear to kind of be leveling out, but I don't know. I think that the best is probably going to be, do you guys agree that it's more quadratic than it would be linear? If we're not sure, we can even do this. Watch. We can go to stat, calculate, and we can go to linear, and we can check that r squared value. You guys do that on your calculator. The r squared for linear is 0.8. That's not great. Let's see if the quadratic's better. If I go down to quadratic, r squared is 0.88. So, it's more quadratic than it is linear. So now we're going to jot down what our equation is. So we're going to have to go with quadratic, even though it's not perfect. So it's going to be y equals 1.49 x squared plus 0.51x plus 39.98. We'll go back to our y equals, and we'll put that in. Is this 0.51 or 5.1? What is it? 0.51. That's what I thought. Okay, so now when we hit graph, see that parabola is not perfect, but it's better than a line would have been. Okay, so that's why we're going to go with the quadratic. Okay, and now it says to use the regression feature of your calculator to find the model that best fits the data. We actually did that here. Put a line to show that's our regression equation. Now it says use the model in part B, which is this, to predict when the budget of the university is $500 million. Am I going to type in am I going to be looking for 500 million on my calculator for Y? The budget's Y. What am I going to be looking for? Not 500 million, just 500, right? So I have a couple ways of doing this. I can go to my table, and I can sit here and scroll down until I find 500. Right around in there. So in between 17 and 18. But that's not real exact. Watch what I can do instead. I can go to Y equals, and I can put in that I want a Y value of 500. So I put that into Y2. Now I'm going to hit graph, and I'm not seeing that. But that's because of my window. I need to make this window go up so that I can see 500. I'm going to make it 600, in fact. Okay, so there's my regression equation. And I can see that that's happening way down here, right? So I have to go back to my window, and I've got to make that X max even bigger. Let's see what happens. There's our function. There's our 500. And so I want to know what is that X right there that's making it be 500. So I go to second trace. What am I going to use? Which one? You guys know? Anybody? Not sure? Look at it again. I want to know what is this X right here. So I actually want to know where they intersect. So I'm going to go to second trace, and I want to go down to intersect. And then it's going to say, is your first curve Y1? I say enter to say yes. Is the second curve Y2? Yes. Enter again. And then I push enter one more time, and it tells me that it's at 17.4 years. Okay, so 17.4 years. Look back at your table. Does that make sense? 17.4 years, does that make sense for when it would be 500? Yeah. Okay, so that's going to be in 17.4 years. Okay, questions on that? So the new thing we did there was intersect. Have we not done intersect in here at all? Have we not used it? Okay, let's go back. Let's just do a simple one with intersect. Put in y equals x and y equals negative x plus 1. We are going to want to turn off our stat plot. So go up to the top and hit enter, and now they're off once it's not highlighted. Do a zoom 6. Zoom 6 takes us back to our normal screen. So if I want to find that point of intersection there, I go to second calc, I go down to intersect. Is that your first curve? Yes. Second curve? Yes. One more time, and it tells me right there's my point of intersection. That's a really nice thing to use. It's very helpful. Any questions on anything? All right. Good job, guys.